Forrest Breyfogle here. In this session, I'm going to be describing KPI and Process Performance Metrics 2.0. The methodology I'll describe resolves commonplace metrics reporting issues that often occur in organizations. No goal or specification is required for application of this methodology. The agenda. I'll be first describing benefits of KPI and Performance Metrics 2.0 reporting. Next, I'll describe how to create 30,000 foot level metrics report and application examples. Now this is where 30,000 foot level metrics are a means to have KPI and Process Performance Metrics 2.0 reporting. Thirdly, I'll talk about conversion of traditional organizations metrics report out to a 30,000 foot level format and the advantage of this conversion. Next, I'll talk about comparison of process performance metrics reporting options that were discussed in this session. And then we'll talk about next steps. The first agenda topic. KPI and Process Performance Metrics 2.0 overcomes the many elephant in the room shortcomings of 1. Process performance indices and process capability indices reporting relative to specification achievement. Process performance metrics or KPI indicators reporting often focuses on how a task is being executed relative to a goal achievement. Now the first item is addressed in an article that can be accessed through the link that's shown. The second item is addressed in this video, an article that can be accessed through the link shown. The described process performance metrics example in this video provides an enhanced measurement reporting technique that requires no specification or goal. The described methodology can provide more insight into what is happening in a process and what could be done to improve its response than ever seen before with a traditional measurement report out. Second agenda topic, how to create 30,000 foot level report and application examples. Our KPI and Process Performance Metrics Reporting 2.0 methodologies is called Integrated Enterprise Excellence, or IEE 30,000 foot level reporting. The two steps for creating a 30,000 foot level report are 1. Determine if a process output response is stable. Now this is from a high level viewpoint where data are from a long period of time, for example, multiple years. When a process is stable, it is considered predictable. Formulate a prediction statement for the latest region of stability in one of the following formats. When a specification requirement exists, report non-conformance rate percentage estimate. When no specification requirement exists, report median or mean response and 80% frequency of occurrence rate estimates. Now note, 80% frequency occurrence rate estimate is a process output variation reporting methodology which provides an expected futuristic response rate for 4 out of 5 reported time increments. If a process prediction statement is considered unsatisfactory, the process needs enhancements. Examples of KPI and Process Performance Metrics 2.0 reporting are shown below, where typical time series reporting frequency is month, week, day, or batch number over a long period of time, for example, several years. Now one example is revenue, which could be reported monthly over multiple years. Expenses, profit margins, customer satisfaction, customer retention, On-time delivery. More examples: non-conformance rate, market share, inventory, cycle time, production yields, employee satisfaction, employee turnover. These are just a few examples of this form of reporting. Conversion of a traditional organization's metric report out to a 30,000 foot level format and the advantages of this conversion. Traditional metric reporting formats could be a table of numbers, classical bar chart, red, yellow, green scorecards, or the balanced scorecards. However, often when these traditional performance measures are presented in a meeting, stories of the past are provided that do not provide a prediction of the future or give direction to where improvement efforts should focus. Typical metric reports and their meetings discussion often give focus to achievement of an arbitrary financial goal for the year, are unrelated to improvement efforts, provide point-to-point comparisons, for example, comparison to last month or a similar month in a previous year. However, Y is a function of X. That is, the output of a process is a function of its inputs and process execution steps. Effective metrics. View the enterprise as a system of processes. Acknowledge the effect of process output variation. Encourage long-lasting systematic process improvement. 30,000 foot level reporting provides a methodology for effective metrics reporting. I'll now demonstrate the transition of an organization's red, yellow, green scorecard metric to a 30,000 foot level reporting format. This is an actual red, yellow, green scorecard that an organization had. Let's examine finance metric B. If we look at this metric report out, we'll see that there's 33% red and 50% green. Now the question is, are these measurements special or common cause? Well, to better understand what special and common cause might be at a high-level viewpoint, let's consider the time it takes to commute from home to work by way of automobile. Now someone observed and they noticed it takes them typically between 25 and 30 minutes to commute. It's not always the same time because they might catch traffic lights differently from one day to the other. So let's consider this person wanted to reduce the time it takes them to commute, so they established a goal of 28 minutes. So if it's 29 minutes, they're going to try to understand what they did wrong or what happened and try to make sure they don't do it again. But if it's 26 minutes and they say, hey, yes, we did a good job, we were able to achieve our goal. Well, that's a problem. You shouldn't establish goals that are in the common cause or the normal variability of how long it takes you to commute. Otherwise, you can have firefighting or you can have stories. So if you have common cause variability, then you need to do something different. So the person say, well, what if I leave a half an hour earlier? I might miss some traffic. So they did that for a while and noticed it takes them now, only 19 to 21 minutes to commute. So they reduced not only the average value, but also the variability of their commute time. Now, if for one day it took them an hour to commute, then they could look into why was that. Well, they noticed there was either a major traffic accident along the way or they had inclement weather. They can talk about those special causes. So with 30,000 foot level charting, we want to really separate these special from common causes so we know we have to work on the process or address special events. Now let's talk more about this traditional scorecard approach. The metric is colored red when a goal is not being met and corrective action needs to be taken. This can result in counterproductive initiatives, 24/7 firefighting, the blame game, and proliferation of fanciful stories about why goals weren't met. But it tells us nothing about what we can expect in the future. So let's re-examine this set of data from a 30,000 foot level point of view. Now the first step is to determine if the process is stable. Now the way you do that is through an individual's control chart where each adjacent observation has variability associated with it and mathematically is used to determine the upper and lower control limits. Now, if we do not have any data points beyond those limits or any trends within this uh, uh, parallel lines region, then we say our process is stable and nothing has really changed. So as you can see, after examining this chart, we notice that the red, yellow, green scorecard has a much different perspective on what's happening than the individual's chart, where the red, yellow, green scorecard, we thought there was an improvement when we had transition from red to green, but in reality we didn't. It was just within common cause variability. Now, if there is a recent region of stability, we can say that the process is predictable. The next obvious question is, what do you predict? If a process is predictable, we can consider the data from the recent region of stability to be a random sample of the future. So we can build this histogram that represents what we think will not only be occurring now, but in the future. Turn it on its side, we look at the area of the curve below 2.2. That represents the frequency that we would have values that are not considered acceptable. However, determining that area in the curve is difficult to do with a histogram. So a better approach is to use a probability plot, in this case a normal probability plot. A probability plot is a better approach for determining this estimate. Now with probability plots we notice that the x-axis is response just like the histogram, but on the y-axis we have percent less than. So in our particular case we follow the 2.2 x-axis value on the probability plot up to the line and over, and what we'll see is now an estimate of the area to the left of 2.2 in the histogram. So we conclude that we have about 32.6% of the time we'll have a response below 2.2. So in ILB reporting at 30,000 foot level, we want to have predictability statement, which we have there, and then provide a prediction statement. The way we do that is provide the normal probability plot in the same report out. Notice now the probability plot provides a variation insight into our process, which Dr. Deming and other gurus have said is very important. How do we present this to others? Well, we can make the statement simply at the bottom of the charts, and that's what is done in 30,000 foot level reporting. If this futuristic statement is undesirable, there is a need to enhance the process. Notice how this prediction statement is a lot easier to understand than process performance indices such as PP and PPK. A free 30,000 foot level reporting app is accessible through the link shown here on the slide. I'll now demonstrate use of this app, which you can freely use for your data. Accessing that link that I provided earlier, you would eventually see the IEE chart builder as shown. The first thing that you would do is locate the data on your computer. This is that finance metric B. I'm going to open that data set. What you'll see on the right hand side is a snippet of the upper left hand corner of that spreadsheet. This app can handle different types of data, but for our situation, no subgrouping is what we want. If we highlight the column name of the data we want to analyze through Control C and then a Control V, we then want to note that we have a lower specification only value, and that's 2.2. Now magically we get a 30,000 foot level chart where it makes a statement at the bottom of the chart of our estimated non-conformance rate of 32.7. Now we can add some niceties to this chart. We can put the title of the column that has our date in it. So we can add the date to the x-axis. We can also enter a chart title, which is finance metric B. The x-axis would be month. Scrolling up, you'll see the entries were incorporated in this chart. Now if we were to right click on this, we can save the image as a PNG file that can be accessed through a PowerPoint presentation, Word document, or so on. Now for this particular situation, is 2.2 a good specification for this response? I don't really think so. I think someone established that because that's what they wanted to do for the next time increment. However, it seems like to me, more appropriately, we really don't have a specification. So instead, we could have a report out that would look like this, where now we have an estimated mean of 2.26 with 80% frequency occurrence between 2.09 and 2.42. Now, if this response is not satisfactory, then what we need to do is to improve our process. Now, for a goal for improvement of this process would probably be dealing with the mean value. We want the mean value to move upward and maybe the variability to reduce. Now, the way we observe that, see if we made an improvement, if actually it occurred, we might have tried, but we want to see it, is that then our individuals chart would transition to an enhanced level of performance. Well, now I'm going to return back to the PowerPoint slides. Hope you found and started thinking about how you could apply that app to your situation. Next, I'm going to talk about the comparison of process performance metric reporting options that we talked about in this session. Talked about the red, yellow, green scorecards and the 30,000 foot level reporting options. A 30,000 foot level statement is much easier to understand as 32.7% non-conformance rate than talk about all the red, yellow, green transition with just process noise and can lead to much wasteful firefighting. If the estimated non-conformance rate of 32.7 is unsatisfactory, process enhancement is needed. I also made the point of maybe we should be examining the mean and median value as opposed to the 2.2 lower criterion, which is probably not a specification and an arbitrary goal. Because of this, as I alluded to, I believe the mean and 80% frequency occurrence is a much better approach. Now, if that mean financial metric and associated variation is not satisfactory, then we need to do something differently. Just don't talk about the ups and downs, common cause variation within the control limits. Now, in addition, this is real exciting, the Integrated Enterprise Reporting System, or EPRS, organizations can have behind their firewall automatically updated 30,000 foot level reporting. This is just one thing that EPRS software provides. It really provides much more. So, final agenda topic is next steps. Many applications of 30,000 foot level reporting and improvements are described in my 2 books here, which were published in the fall of 2020. Its Management 2.0 provides 7 illustrations of 30,000 foot level reporting. Leadership System 2.0 provides 13 illustrations. These novel written books are available in paperback, ebook, and audiobook formats, and they provide much more than just 30,000 foot level reporting. It pulls together a whole system for organizations. 30,000 foot level charts can provide valuable, never seen insight into virtually all processes. To see the power of this enhanced approach, you really need to set up a free half-an-hour Zoom session with me. In this session, I can show you the application of 30,000 foot level reporting to one of your Excel process output reported data sets. That meeting can be set up through the web page on our Smarter Solutions homepage near the bottom, or you can give us a call or email us. I'm really excited about the value of 30,000 foot level reporting to organizations and how they can help drive the right kind of activities for the various measurements they have throughout their organization. So hopefully you'll take me up on my offer here. I have a passion about 30,000 foot level reporting, and I want to share it with others so they can benefit too from the methodologies. Thank you for listening to this session. Hopefully we'll touch base soon.